All right, guys, welcome back, and we're looking at example 4. And example 4 says, given m of x equals 11x plus 3, determine 1, m of 2, and part 2 says, determine the value of x when m of x is equal to negative 1, and part 3 says, determine the inverse of m of 5. But remember, we can't find the inverse of m of 5 unless we find the inverse of m of x first. So sometimes I give you this, and you should know that you need to find the inverse first before you find that. So let's go ahead and do the solution to this question. And just again, see trends and similarities that occurred in the first 3 examples. So let me just put this here so everybody can see it while we're working. All right. Okay. So again, it makes sense to write the original function, and that original function is m of x, and m of x is equal to 11x plus 3. That's the original function. Now part 1 is requesting that we find m of 2, which means everywhere you see x, you're going to put 2. So 11 times 2 is 22, and 22 added to 3 will give you 25. Now for part 2, it says determine the value of x when m of x is equal to minus 1, which means the function itself, 11x plus 3, is equal to negative 1. So 11x would be equal to negative 1 minus 3. When you carry over the positive 3, it becomes negative. So 11x equals to minus 4, and x will be equal to minus 4 over 11, which is the same thing as saying the negative 4 over 11. So that would be the answer to part 2. Now for part 3, they're asking us to find the inverse of m of 5. But of course, we need to find the inverse of m of x first. So to find the inverse of m of x, we're just going to write the original function again, so it's a good practice. And then follow the steps. Let y equal 11x plus 3, and then interchange. And when you interchange x and y, it simply means just switching their positions. So x comes here, we're going to have 11y plus 3. And then finally, we're going to solve for y, which means, again, make y the subject. So I'm going to write this back. And the first thing we're going to do is move 3, take it over, it becomes minus. And of course, x minus 3 divided by the coefficient of y, which is 11. And this will be equal to the inverse of m of x. So the inverse of m of x is equal to x minus 3 over 11. Now this is what we're going to use to determine what the inverse of m of 5 is. So I'm just going to slide this up, and we have to pay attention to what the inverse is here. So to answer what they're asking for, since the inverse of m of x is equal to x minus 3 over 11, then the inverse of m of 5 simply means wherever x is in the inverse, we're going to put 5. So 5 minus 3 over 11. So the inverse of m of 5 therefore is going to be 2 over 11. And that is going to be the solution to example 4. Quite simple, quite straightforward. Right? Comes with a little bit of practice, but afterwards you'll see the trend. Again, the original function is 11x plus 3, and look at the inverse, x minus 3 over 11. So these are what we call the simple functions, and it's very, very easy to say and anticipate what the inverse is going to be after you've worked several examples of these. So by now you should realize that these questions and functions are not difficult, and the next step that we would migrate to is looking at functions that are in fractional form. All right, but before we do that, we're going to have to look at giving you guys some questions and see how we manage with these simple functions. All right, I hope you found this video insightful, and I'll see you guys on the next video.